Good morning, friends. I am your Dr. M.H. Annaya, and in today's video, we are going to work out a problem on the isometric drawing. That is, given the isometric drawing of a simple machine components or a casting, we need to obtain how the object looks when viewed from the front view, when viewed from the end, that is left hand view, and similarly when it is viewed from the top, we would like to know how does the object look. So we need to find out the front view, the end view, and the top view. They are called the orthogonal views of the solid. Friends, to make this process very simple, first of all, I have marked an XY line, and then I have just made a box in the front view, in the top view, and also in the end view. Friends, if you look at the board, in the front view, the maximum width is 80. That 80 I have marked here. The height of this box is 50 mm. 50 I have marked. Similarly, in the top view, you have width is equal to 50 and length is equal to 80, because in the top view, you can see the length and width. So I have marked 50 and this is 80 as usual. Friends, and in the end view, it is 50 millimeter wide and height is equal to same as the front view height, that is 80. So by marking these rectangles in the front, top and end views, it will be easy to draw the orthographic projections of a component like this. So friends, let us start with the drawing of the front view of the solid. Friends, the front view depends on the position where you stand and see. So if you stand, they have given clearly, you have to look from this direction perpendicular to the board and see how does the object look. Friends, if you see the front view, assume you have a torch, a light with you. If you just put the light on this, the vertical faces, that is this L-shaped object, is seen in the front view. So friends, I am going to make this rectangle that is 25 millimeter height. I given here 10 plus 10, this is 20 throughout. So I have shown somewhere, I will mark it again, not an issue. So this has got a height of 20 mm. 20 mm by this 80, we are going to have a block like this. So I will write a horizontal line in the front view to show a height of 20 millimeter. And friends, here what we do, I write a vertical line to get this inverted L shape. So friends, I am going to get this. So this is the part I am writing. I have written this line, a horizontal line, a vertical line through that to the given height of 50 mm. Then I am completing the part, the portion of that solid by drawing lines like this. Friends, this is how this L shape of the object looks. So this is what I have drawn, friend. Next, friend, in the same page, you have got a trapezoidal slot, a cutting made throughout this 50 millimeter depth. So friends, I have to construct this trapezoidal shape cutout. So friends, here it has got a width of 30, height is equal to 12. 20 at the top, 30 at the bottom, and it is exactly in the center of this face. So friends, I mark the center of that face, means totally from that end I have to mark 40 millimeter. Friends, maybe somewhere here you get that 40, that is exactly in the center. I take a distance of 40 millimeter here, and friends, here the slot is visible to us, this part. So at the top it is 20, at the bottom it is 30. So I am going to mark a line here at a height of 10 millimeter, and at the top it has got a width is equal to 20 mm. That is clearly visible to you. This is 20 mm and here it is 30, means you have to take 30 mm on a 15 millimeter on either side. Friends, this line here will not exit. That can be shown by a very thin line because that slot is there throughout the depth of that. Friends, I have written this L shape. That L shape is here. Then I have made this slot exactly in the center. This is 15 millimeter, that is 20 millimeter, and this is 30 mm at the base. It is a trapezoidal slot. And friends, this height is equal to 10 mm, that you can see there. This is 10 millimeter height. Friends, I have completed all this part. But remember friends, there is also a slot cut throughout this depth of 80 millimeter, that is rectangular in shape, 20 by 10. Friends, that is not visible to us. So that has to be shown at the same height, but it is there throughout from this line till the 80 millimeter. So friends, I am going to mark that by an invisible line, a dotted line having the same thickness, the height is equal to 10 mm. So this indicates that there is a slot going throughout the length of 80 millimeter. Friends, what else you see? See, there is a hole drilled here on this piece perpendicular to that. That is not visible in this view. So for that diameter, they have given at a distance of how much? 15 millimeter from this. So from here, I will take 15 millimeter and mark the center of that. And the diameter it has got is 20 mm. So I will take 10 mm on either side. And since this is not visible, friends, I will show it by a dotted line. So a dotted line here, this is a center line, again a dotted line. Friends, excuse, this has got a diameter of 20. I will call it as 520. Diameter is 20. Friends, we have marked this front view. We have marked this slot exactly at the bottom, in the middle of this, and there is this slot, rectangular slot, which is shown in the front view as a horizontal line, dotted line, having a depth is equal to, that is 10 millimeter. Friends, we have marked complete front view of the solid, including the hole, the trapezoidal slot, the rectangular slot, which is horizontal. Friends, let's move on to the top view and see what all exists in top view. Friends, if you look from the top, you have a rectangle here, you have another big rectangle here. So friends, we have this rectangle and I will show that by a dark line now, and that rectangle will have the dimension of how much? The total dimension is 50 by 80. So friends, I am going to have this rectangle drawn first, and there is this small rectangle having this dimension as 20, same throughout, 20 by that height, total height. So friends, that can be obtained like this. You can extend a thin line from there, and friends, here you are going to have one rectangle. This rectangle will have the thickness 20 and this is by 50. This is the other rectangle. This rectangle is this rectangle which is seen from the top. Friends, again, you have a hole drilled on this piece, So at what distance? It is exactly in the center. So exactly in the center, I will just mark a center line and take 10 millimeter on either side of that to represent the hole drilled in there. It is not visible, so we have to show it compulsorily by a dotted line. That is to show that there is a hole drilled. This hole diameter and this hole diameter will be same. And this hole can be seen only in the end view. That I am going to do it later on. Friends, we have got this slot, we have got the rectangle. Then there is, friends, right in the top view, there is this slot. When you look from the top, you will have one line from here, one line from here, one line, one. So totally four lines will be there running parallel to 50 millimeter edge. Friends, so where that will be exactly in the center. From this, you can simply extend and get it. According to my figure, this is one of the lines, this is the second line which is not visible to us. Again from this end, another line. So these are the four lines you are going to get. All these four lines are just standing here. So one line here I have shown here, the other line. Since the drawing is made freehand, no, maybe the concept you will get correctly, but the exact location may be slightly different. Friends, this gap will be, look here, this is 30, this is 20. Each gap will be 5, 5. So this will be, just to explain, I am telling you all this. There is no need to mark any of it. This is 5 millimeter and this is also 5 millimeter. This is 20 at the top, 30 at the bottom. Friends, we have shown this slot. We have shown the hole. Friends, finally we have to show this rectangular slot which is there throughout exactly in the center of what are the thing you have got here that you have to extend and get it. Friends, that slot is exactly at the center of this 50 millimeter side. So from here, friends, from the center of this, I will take on either side 10, 10. So 10 on this side. That slot is not visible in the top view and hence I show it by, that is exactly to coincide for the kind information, because this is diameter is 50, this is also, sorry, diameter is 20, so you are going to have a line here coinciding with that line already drawn for the hole, because they have the same diameter. So friend, one more line you are going to get. These two lines are drawn here to show the rectangular slot which has got a width of 20. The whole diameter is also 20. Hence I have shown them lying on the same line. Friends, we have shown the that is hole in the vertical face here, and then the slot cut parallel to this edge, that also have shown in the top view, yes. And then the horizontal rectangular slot cut along the 80 millimeter dimension, that also is shown. Friends, this figure will give you the front view, and friends, this is the top view. And friends, let us see what do we see in the end view. Friends, for getting the end view, they have given the direction, means you will have to see from this side. Friends, if you see from this side, it is very obvious. You have got a rectangular face, something like an inverted C, that you are going to get up to what height? 20 from the bottom. So simply you can extend this line, friends. This line if you extend throughout, so you are going to have a slot in that face. So this is the face I am writing this top line, and then there is a slot here. That slot I will mark here. And this slot width is 20, so that if you extend this line up to here and take upwards, also you will get the same. So this is a slot you have got. Yes, this slot I have written, this space I have written just above this. This line coincides with this when you view from this side. So friends, on this you are going to have one more rectangle, that is the vertical rectangle, and I will show it by a vertical line drawn straight, and this has got a width is equal to 50, this is 50, and finally this is the last line of that. And friends, you have a hole on this face, and that hole, to obtain that hole, you have to extend the center line of the hole, locate the center of this, because the hole is exactly in the center. So exactly in the center. So I am going to construct a hole of this diameter. So there will be a clear cut hole. You can just draw that. This hole is seen throughout, and friends, you have shown this slot, this inverted C you have shown, then you have shown the circle which has got a diameter of 20 mm, and then what else is left over, friends? when you see from here, this slot is moving to the left, from right to left. How to obtain the front view? See, at a height of 10, you have this slot running through. So you get one line for this, one line for this. So one line is here, this is one line. Since this is 10, this is also 10, it coincides. So this is the slot. So you have one line from here, the base line. That's all you have got. Friends, you have got the front view. Front view will have a shape like this, and we have shown clearly what are the dimensions of that. And friends, this is the front view you have got totally. I am showing once again by visible line. This is the front view. And the front view, you have this trapezoidal slot that is shown here at the bottom. This line is not there because there is a hole throughout. So that appears as two dotted lines in the top view because you cannot see this corner, this and this in the front view you can see. In the top view they are shown by dotted line. Then friends, in the top view you have box 50 by 80. In the top view this is 80 and this width is 50. I have constructed a box, and there in the top view you will see this rectangle. This rectangle at the top is this rectangle. Then this rectangle is shown by this figure, another rectangle. So two rectangles. There is a hole drilled here that is shown by dotted line with center line mark. And in the end view, friends, you will be able to see this inverted C. This shape can be seen here, that I have shown here. And the height of this slot and this slot, they are the same and they coincide, but you don't have this line here in the end view. Friends, this will give you the left end view or left side view or left profile view. And this profile view is obtained on the right profile plane, RPP. RPP is the wall which is perpendicular to this VP, which comes to your right side. Means RPP is to your right. Friends, this is how we obtain the isometric or the orthographic projection. These three views are called orthographic views of the given solid which is shown in 3D. So this is a three-dimensional figure and that is converted into a two-dimensional figure. These views are called the orthographic views, whereas this is called the isometric view. Remember friends, in isometric view or isometric drawing, we do not use any scale such as the isometric scale. So we make use of isometric scale only when the figure is drawn to a reduced scale. That is, in the isometric projection, whatever the dimension you have got, the same figure, if it has to be drawn using isometric scale or isometric scale, then this 50 is to be multiplied by 0.815. So it gets slightly reduced by approximately 19% in all the dimensions. Friends, I hope the presentation was interesting. Please go through the complete video, and if you have a liking to this video, give a liking and share the information with all your friends without fail. Do not forget to share the information about my channel, that is Engineering Drawing by Dr. M.A. Channaya, and I have around 200 problems on various chapters like planes, solids, lines, isometric projection, development, etc. So if you go through all these problems, I am very sure you will be able to any question in the examination. That is the experience. Based on the experience, I am just advising you. Friends, thank you very much for watching my YouTube video. Have a wonderful day.